right, everyone. So you have a second warm-up packet. So this is the rest of the warm-ups that you have for today for this unit. And I did upload the agenda for the rest of the unit. So we're going to wrap up this unit mid-May, 16. And we do have a kind of a fun electrical engineering activity or project that you're going to do as well. So so you can look at that at your disposal. We have one more quiz, which I think is going to be next week. And then we'll get into the rest of circuits, which we're starting today. And then we're going to do a quiz on that, our fun project, and then wrap up this unit, and then we have one more unit to go. So this last kind of month, or this last section of school goes by super duper fast. We don't have a break to catch up with materials, to try to keep up with materials. I also have these worksheets. So normally you would read chapters, you would take notes, and then in the end, I would stamp whatever notes you felt were important. To highlight the important parts, we have these worksheets. So you don't have to necessarily take notes on the readings anymore, but you do have to read, and then from that reading, answer the questions on each chapter. And it has some practice problems, which are really good review and practice for quizzes and tests. So for tonight's homework, you're going to read a set of chapters. I'm not going to stamp the fact that you read them, but I am going to stamp the fact that you are completing these worksheets, which require you to do the reading. And so no more notes, just reading and filling out these. Okay, so let's get into this warm-up for your new packet. And thankfully, it was stamped in order. I gave that job to Miss McGarry because I screwed up the other warm-up packet. But we already talked about electric fields last class. And so you're going to sketch what direction these charges are going to move using arrows. And in the beginning, they're positive charges. So how are these positive charges going to move? In an electric field, that is a line of positives and a line of negatives. And you did this as a challenge within your group when you did the Jamboard. In the next question, it introduces you to a new vocabulary word. The new vocabulary word is electric potential energy. We learned about potential energies in our energy unit, which was gravitational potential energy when you have an object above the ground. And there was elastic potential energy when you have energy in a spring or an elastic rubber. Now, potential energy, because it has potential to create change, is stored energy. So electric potential energy is stored energy. Now, it's very much related to force, and we already understand the relationship between force and distance. So the greater force you have, the greater electric potential energy is there. Does that make sense? So if you think about charges, because they act like magnets, if you push two like magnets together, two negatives or two positives, you're going to feel a strong force of repulsion, right? That force, as long as you don't let those magnets go, it's going to be a potential force because it's stored and it's not moving until you let it go and then you get kinetic energy, some sort of motion. That's what electric potential energy is very much related to. So I want you to think about that when you're answering question B. And then the second part is, what would happen if the two charges A and B were negative instead of positive? So think about how it would interact in an electric field created by these lines of charges. All right? I'm introducing a few new things to you in this warm-up, so do your best. We'll talk about it And then we're going to get into some fun stuff. I think this is the best part of our electricity unit, is actually creating some circuits and making things light up using electricity. So you're going to play around with it first, and then we're going to do, I know some of you've noticed some of the electric houses in the back. We're going to do that electric house project by the end of this. So it allows you to, pretend you're an electrical engineer and that you're building a house and creating these circuits.